What if the future of space doesn't arrive from rockets alone, but from sunlight above Earth? In 2026, revolutionary missions will cross planets, fly past worlds, and rewrite our map of the solar system. At the same time, solar-powered aircraft could challenge Starlink's dominance, reshaping how humanity connects, explores, and prepares for its next giant leap into a future where technology and exploration merge beyond imagination, changing history forever ahead. The year 2026 is not just another date on a calendar. It represents a turning point for humanity's relationship with space. Multiple space agencies and private companies are preparing missions that will reshape how we explore the solar system. Flybys will bend spacecraft trajectories with planetary gravity. New probes will gather data never seen before. These missions are not isolated events. They are part of a larger transformation where space becomes more accessible, more competitive, and more essential to life on Earth. From communication to exploration, 2026 marks the moment when space technology stops being experimental and starts becoming infrastructure for civilization itself. Today, Starlink dominates low Earth orbit with an unprecedented scale.
Look, it is
Thousands
working.
of satellites
The whole
circle the
world is
planet,
here.
delivering internet to remote communities,
I can
aircraft,
finally see
ships
my
at sea,
family.
and
Signal
military
locked. Data
operations
stream
worldwide.
active.
This network has transformed
Confirmed.
global connectivity
Patch the
and
coordinates to the
proven
main
that
display.
space-based internet can be fast, flexible, and commercially viable. But dominance also creates dependency. Governments, companies, and entire regions increasingly rely on a single orbital system controlled by one organization. That reliance raises uncomfortable questions about resilience, security, and long-term stability. What happens if satellites fail, collide, or are disrupted by space weather? What if access becomes restricted during conflict or crisis? History shows that monopolies rarely last forever. They invite disruption,
We have a red
regulation,
anomaly
and
over the Atlantic
alternatives.
sector.
In technology, challengers
Rerouting
often
data
arrive
stream
from
now.
unexpected
Stand by for
directions,
confirmation.
solving the same problem in radically different ways. In space, innovation moves faster than policy. Launch costs fall, platforms diversify, and new layers emerge between Earth and orbit. As reliance on low Earth orbit
The
grows,
object is accelerating.
vulnerabilities
Trajectory
grow with
indicates
it.
an impact within the
The
hour.
very
Can we confirm
scale
its
that
origin?
makes Starlink
Still
powerful
unknown, General. We
also
only track
makes
the
it
red
fragile.
pulse.
Redundancy becomes essential. Competition becomes inevitable. The future of connectivity cannot depend on a single layer or a single provider. To support exploration, commerce, and security beyond Earth, humanity must build systems that are distributed, adaptable, and prepared for failure as much as success. Without such balance, progress slows, risks multiply, and humanity's ambitions in space become constrained by preventable technical and strategic limitations that threaten long-term planetary expansion. Above commercial air traffic, inside the thin stratospheric air, a different vision of connectivity is taking shape. HAP Alpha is a high-altitude, solar-powered aircraft designed to remain aloft for months at a time. It does not orbit Earth, yet it can deliver coverage similar to satellites, hovering precisely where it is needed. Powered entirely by sunlight, it avoids rocket launches, orbital congestion, and long deployment delays. When disasters strike, networks fail, or demand suddenly shifts, HAP Alpha can reposition quickly and restore communication within hours. Its altitude allows wide coverage while maintaining far greater flexibility than space-based systems. Sensors, relays, and communication payloads can be upgraded, repaired, or replaced without leaving Earth. This approach challenges the long-standing assumption that global connectivity must come from orbit alone. Instead, it introduces a layered model where near-space platforms complement satellites rather than compete directly. For governments, industries, and researchers, this means redundancy, resilience, and reduced dependence on any single network. What once seemed experimental is now maturing rapidly. As technology improves and costs fall, HAP Alpha represents a practical, scalable solution for the next era of global communication, surveillance, and data infrastructure, supporting humanity's expanding presence beyond Earth. This capability reshapes strategic planning, enabling continuous coverage, rapid response, and sustainable operations across critical regions worldwide globally. This is not a battle between solar planes and satellites. It is evidence of a deeper transformation in how humanity builds space infrastructure. The future will not rely on a single layer above Earth, but on multiple interconnected systems working together. Satellites will continue to explore deep space and provide global coverage from orbit. High-altitude platforms will offer adaptable, localized services closer to the planet. Each layer fills gaps the others cannot. Together, they create redundancy, flexibility, and resilience. As humanity prepares to operate across the Moon, Mars, and beyond, dependence on any single technology becomes a liability. The lesson is clear. Progress in space is no longer about replacing one system with another. It is about integration, balance, and designing networks that can survive uncertainty, disruption, and rapid change in an increasingly connected cosmic environment. While near-Earth technology evolves rapidly, deep space exploration continues its steady acceleration. In 2026, multiple missions will perform critical flybys across the solar system. These encounters use planetary gravity to reshape spacecraft trajectories, conserving fuel and extending mission lifetimes. Flybys are not shortcuts. They are precise calculations
the burn is complete.
Executed
we have
at extraordinary
signal,
speeds and
the
distances.
maneuver was successful.
Spacecraft
Great job,
bound
everyone.
for the Moon, Mercury, Jupiter, and distant asteroids will rely on these maneuvers to reach their targets. Each close pass provides valuable scientific data, revealing planetary atmospheres, magnetic fields, radiation environments, and surface composition. These missions also test autonomous navigation, long-distance communication, and system reliability far from Earth. Every successful flyby represents years of planning, compressed into seconds of execution. Together, these missions form a coordinated expansion of human presence throughout the solar system. They support future lunar infrastructure, prepare pathways toward Mars, and refine techniques required for crewed exploration beyond Earth orbit. In 2026, the solar system no longer feels static or distant. It becomes an active environment shaped by gravity, motion, and technology. Each flyby connects worlds through physics and precision. Each mission adds another piece to humanity's growing map of space. This expanding network of exploration is not driven by curiosity alone. It is driven by preparation. The skills, data, and systems developed during these missions will determine how far humanity can safely travel, how long it can remain, and how effectively it can operate beyond its home planet in the decades that follow. The hidden connection linking these stories is communication. Deep space missions depend on continuous data flow. Navigation, timing, scientific discovery, and system health all rely on stable connections with Earth. Whether signals pass through orbital satellites or high-altitude platforms, connectivity is the invisible backbone of exploration. Without reliable links, flybys fail, data is lost, and missions collapse. As humanity moves farther into the solar system, communication systems become as critical as propulsion. The future of exploration depends not only on where we travel, but on how well we remain connected across vast cosmic distances. In 2026, space is no longer distant or abstract. It surrounds humanity through technology, exploration, and connection. From solar planes to deep space probes, the future is arriving now. Subscribe to follow the next chapter of humanity's expanding journey beyond Earth.